One of the first and most important steps to optimizing your costs is being able to understand them. Today, we'll talk about a few different ways to understand your Google Kubernetes Engine costs and go over a few best practices. Let's go beyond your GKE bill. If you haven't watched the last video, I definitely recommend taking the time to check it out, since we talked a bit about teams and culture. These concepts are super important for being able to get a solid understanding of your costs. I'll start by giving an overview of some ways that you can understand more about your GKE infrastructure and applications. Then, I'll go over how to turn these details into actionable steps, and then finish up with some cost optimizing policies. Your organization might have a platform and infrastructure team that manages the clusters, which can be completely separate from the dev team that actually write the applications. When every team understands the cost implications for the decisions they make, like how many resources an app actually needs, they can all work together to get things optimized. So, where do you start? Well, that's probably going to be the monitoring dashboard. When using GKE, the cluster's info page shows a lot of details, but we're looking for some details about our metrics. So, let's head over to the monitoring page. This is part of Cloud Operations, which has a bunch of helpful functionality for monitoring, logging, and alerting. If it's your first time using Cloud Operations, you'll have a workspace created for you, or you can create one manually. Either way, as long as your cluster was set up with Cloud Operations for GKE, a dashboard will automatically be created named GKE. This dashboard gives us the ability to see our Kubernetes information over a time series, grouped by cluster, node, pod, and container. We're on the Infrastructure tab, which is a perfect view to get more details on the CPU and memory utilization, and if there are any issues with the nodes. The Services tab gives the same information, but from a service-centric point of view, useful when there's a service disruption. There's also a Workload tab that gives you an app-centric view. This view is a helpful way to get an idea of what's going on, but we can also get more detail by using the Metrics Explorer. Here, we can create custom charts with options to filter, group, and aggregate. For instance, we can create a chart that would let us see the CPU usage time by container. You can even create a custom dashboard that shows more custom charts. If you use cloud logging and cloud monitoring to provide observability into your apps and infrastructure, you're only paying for what you use. However, the more that they log, and the longer you keep those logs, the more that you'll pay for them. Plus, the more external and custom metrics you have, the more you'll pay for those as well. There's a link in the description that gives a great overview and lots of tips on cost optimization specifically for logs and monitoring. Also, we talked about multi-tenant clusters before, and if you're using those, you probably want to make sure that you're sending the logs back to the tenants for their usage. The cost savings tip here is to use exclusion rules so that you can filter out the logs you don't care about before you get charged for them. There's another link in the description that goes over setting that up. Okay, so we've seen the built-in dashboards, but that might not even be enough. If you want to get even more granular, you can enable GKE usage monitoring to set up automatic collection of metrics and then export them to BigQuery. Once in BigQuery, you'll be able to see specific usage of CPUs, GPUs, TPUs, memory, storage, and even network egress. These details can be used to compare actual usage versus allocated resources, and then you can figure out where you might be over-allocated. Following the best practice of splitting teams or apps by namespace also gives you the ability to easily see the resource usage and cost for each one. Labels can also be used for filtering. The most important thing is to consider the culture suggestions from the last episode, and help make teams aware and even accountable for the costs that they incur. Remember, high cost doesn't automatically mean that something is wrong, but you don't want to pay for things that you're not using. Now that we've gone over the monitoring side, let's take a look at some ways to take action on those insights. With the ability to see exactly how resources are being used, you may also want to use Kubernetes Resource Quotas. Resource quotas let you cap the amount of resources that a namespace can use, which is another great reason to use multi-tenant clusters to split up by namespaces. This can help you keeping any tenant from consuming too many resources, which might then trigger auto-scaling. Limit ranges are another way to enforce resource limitations, but they're actually at a pod and cluster level. The real value comes from understanding detailed metrics and using those to set appropriate quotas. If you're using a version of Kubernetes that supports a metric server, there's some good things to know. The metric server helps collect and then expose metrics through the Kubernetes Metrics API. When an application is using a lot of resources, the metric server can be used to figure out when you should autoscale. That's great, but the metric server is still a deployment itself, which means that it actually needs to be running somewhere. As a cluster gets more nodes and deployments, the metric server needs to grow along with it. However, when it's time for the metric server to grow, it has to be restarted. If your cluster is changing quickly, this could mean a lot of restarts, which could then cause a small delay in autoscalers. And even small delays in autoscaling can add up to big impact. So, the best practice here is to make sure you work with your metric server. Newer versions of GKE support a resize delay to help keep your metric server from restarting as often. Make sure that your version supports the scale down delay to avoid too many restarts, and ensure that you monitor the metric server as a top priority to avoid potential autoscaling issues. Another way to avoid potential issues is to make sure that any configuration changes are reviewed before they get deployed. So, if a team unexpectedly updates a config with 1,000 replicas, you can deal with it before it spikes your costs. The Anthos policy controller is one way to help automate this by checking, auditing, and enforcing those policies that you've created. These policies can help you control security, regulations, and custom business logic that might affect your costs or your application stability. In addition to this, you can use a tool like Kept to build this logic into your CI/CD pipeline, so you're automatically validating any configurations through the development cycle. It's also a good idea to keep your eyes on the recommendation hub. All kinds of recommendations come up here, from security to cost. These are based on your usage, so there's specific suggestions for how you might be able to make changes and might be able to save money. For example, based on your usage patterns, you could optimize your compute costs by purchasing long-term commitments. We'll talk about that more in the next video. The key here is having visibility into what resources your deployments, namespaces, apps, whatever are actually using, and understanding how you can optimize around that. On the next video, we'll talk more about optimizing your costs based on the machines that actually run the applications. Remember to check out the link in the description for the full guide on GKE cost optimization.